In Chapter 10, we are looking at the variances. In this particular problem here, it says that we build houses and tool sheds, and it gives us the following standard costs. So this is what we think is going to happen. We have the lumber, which would be our material, and then labor. We built 4 tool sheds, and we used the following resources. So this is going to be our actual. So it wants us to calculate the direct material and the direct labor price and quantity variances. So let's start off and do the direct material variances first, or look at direct material. So we want to calculate the price and efficiency variance for direct material. Now remember, for our variances, the easiest way to calculate these is to use your 3 columns. So remember, column number 1 is actual price times actual quantity. Column number 2 is standard price times actual quantity, and column number 3 is standard price times standard quantity. So once you have your 3 column headings, you're really just filling in everything that you know. So we first start off with actual. So we're dealing with the material, so we're looking at the lumber, and it tells you what we actually used was 1,700 feet, and the price was 42 cents per foot. So your actual price is 42 cents. And your actual quantity is 1,700 feet. So if I do 42 cents times 1,700 feet, that gives me actual material cost of $714. Now I want to fill in column number 2. Now I'm looking for the standard price. So how much did we think we were going to pay for the material? So it tells us here that for the lumber, that we thought it was going to take 500 feet to make a unit, and that the cost was going to be $400 per 1,000 feet. So to figure out your cost per foot, okay, so for the standard price, we really want to find our cost per foot. So I can take $400, divide it by 1,000 feet. So your standard price is 42 cents per foot. Okay. I'm sorry, it's only 40 cents per foot. I'm sorry. So to get that standard price, I'm going to take the $400 per 1,000 feet. So that gives you 40 cents per foot. So I'm going to multiply that by the actual quantity, which is 1,700. So I have 40 cents times 1,700 feet that were actually used. So that gives me 680. Now, if I look at the difference between column 1 and column 2, if you notice, the thing that's different between the two is the price. See, in column 1, I'm using actual price. Column 2, I'm using standard price. So the difference is the price. So that's how you know that it's the price variance. So to come up with the price variance, I'm simply taking the difference between 714 and 680. So I have a $34 material price variance. So I have a $34 material price variance, and I have to say whether it's favorable or unfavorable. Well, you're dealing with the price, and to me, the easiest way to look at that price is to simply look at what you think you're going to pay and what you actually paid. So we think we're going to pay 40 cents a foot. We actually paid 42 cents a foot. We had to pay more. That's bad. So that gives you an unfavorable variance. Now we can fill in the third column. The third column is your standard price. Again, that's 40 cents a foot. Now we want to multiply by the standard quantity. Now remember, the standard quantity is the trickiest part. Remember, for standard quantity, what you're really looking at is your standard quantity per unit times the actual number of units produced. Because what we're trying to figure out is at the actual production level. Okay, so when I build 4 tool sheds, how many square feet of material should I have used? Well, we think it's going to take 500 feet a unit. We built 4 sheds, so basically what we're saying is that it should have taken us 2,000 feet of lumber. Okay, so I take the 2,000 feet of lumber and multiply it by the 40 cents. So we think we should have paid $800 for the material. Or we thought the material cost would be a total of 8. Now, for the variance, you're just taking the difference between column 2 and column 3. If you look at that difference, or if you look at these two columns, you'll notice the difference has to do with the quantities. Okay, so that's giving you your quantity variance. We could also call it a usage variance or even an efficiency variance. How did we use the material? How efficient were we with the material? So your difference between column 2 and column 3 is $120. So this is your quantity variance or your usage variance. Again, we have to say whether it is favorable or unfavorable. So to determine, you're just looking at the quantities. So we thought we would use 2,000 feet of lumber. We actually used 1,700 feet. So we used less than we thought. So that's good. So that's a favorable variance. So we have a $120 favorable material usage variance. Now we can calculate the same variances, but now we want to do it looking at the direct labor. So same thing again, we want to write down our three columns. So actual price times actual quantity is column number 1. Column 2 is standard price times actual quantity. And column number 3 is standard price times standard quantity. For the direct labor, fill in everything that we know. For the labor, for the actual price, we actually paid the workers $11 an hour. And we had to pay them 15 hours. So the total cost was $165. Then for column number 2, we want to take the standard price. We're looking at labor. So for the standard, we think that we should have paid $10 an hour. Okay, so that's how much we think we should have paid per unit. Still the same actual quantity of 15 hours. So that's going to give you $150. So now again, the difference is your prices. So that's going to give you the price variance. So your price variance here is $15. So you have a $15 direct labor price variance. We have to say whether it's favorable or unfavorable. We thought we were going to pay the workers $10. We actually had to pay them $11. So that's an unfavorable variance. Now we fill in the third column. We're looking for the standard price, which again is $10 an hour. Multiply it by the standard quantity. Again, this is the tricky part. Up here under standard, it says 4 hours. So we think it's going to take us 4 hours to make each unit. And we actually produced 4 units. So when we produce 4 units, we think it should have taken a total of 16 hours. So that's your standard quantity. So I take these 16 hours times the $10 standard price or standard rate, and that gives me $160. So now I can calculate the labor efficiency variance, which is your quantity. And so your difference here is going to be $10. So you have a $10 direct labor efficiency variance. And we have to say whether it's favorable or unfavorable. Well, we thought it was going to take 16 hours. It actually only took 15 hours. That means the workers were efficient with their time. They worked quicker than we anticipated, or more efficiently than we anticipated, so that's a good thing. So it's going to give you a favorable variance. One last thing to note on this problem is when you're dealing with labor, sometimes they refer to the price variance as the rate variance. So sometimes we call it a direct labor rate. So therefore, they will refer to the price variance as the rate variance. But again, I mean, the only thing that's changing is the name, nothing else. Now we have a couple of conceptual type questions about your variances. Question number 2 says, which of the following statements regarding standard cost systems is true? It says favorable variances are not necessarily good variances. Well, that's false because favorable means it is good. Managers will investigate all variances from standard. They definitely can and sometimes will. So we definitely want to keep that in mind as we read the next couple of answer selections. It says the production supervisor is generally responsible for the material price variance. Well, if you think about this, the production supervisor is definitely supervising the workers and supervising production. However, the production supervisor doesn't have anything to do with purchasing, and purchasing is where your material price variance would come from. So C is also incorrect. It says the standard cost cannot be used for planning purposes since costs normally change in the future. Which standard cost is just the cost we think we're going to have. That is what you're going to use to budget because that's what you think is going to happen. So your best answer here is B, that managers are going to investigate all those different variances. Question 3 says a company would most likely have an unfavorable labor rate variance and a favorable labor efficiency variance if. Okay, so let's think about this. Basically, if we have an unfavorable labor rate variance, that means we had to pay the workers more than we anticipated. Okay, so we had to pay them a little bit more, but we have a favorable labor efficiency variance. That means they worked really quickly. They were very efficient. So a reason you could have that is because you could have hired a group of highly experienced workers. If they're experienced, they're going to work very efficiently and be good at their job, which would give you a favorable efficiency variance. But because they are experienced and good at their job, you're potentially going to have to pay them more, so that would lead you to an unfavorable rate variance. So that's why your answer choice A is correct. Number 4 says if actual direct labor hours are less than standard direct labor hours allowed, and overhead is applied on a direct labor basis, what kind of variance are we going to have? Now, I realize we did not talk about in this chapter any variable overhead variances. However, I want you to note that variable overhead variances are identical to direct labor variances, because instead of using the price that we pay the workers, the only difference is now you're using the variable overhead rate. And the rate is based upon and applied on the direct labor hours. So if you have a favorable efficiency variance for labor, you're going to have a favorable efficiency variance for variable overhead, okay? Because the rate is based on direct labor hours. The quantity is the same for both. If the direct labor hours are less than the standard direct labor hours, then that means if actual is less than standard, that means that it's favorable. That means that it's good. That means that we were efficient. So your labor efficiency variance is going to be favorable, and your overhead variance is also going to be favorable. So they're going to be the same. Question number 5 says that Ronald Corp incurred 2,300 direct labor hours to produce 600 units of product. Each unit should take 4 direct labor hours. We apply variable overhead to production on a direct labor hour basis. The variable overhead efficiency variance is what? So again, variable overhead is identical to labor. So all you're comparing is the standard quantity. So you're comparing standard direct labor hours to actual direct labor hours. Okay, so it's the same as labor. Nothing's going to change. So for your actual direct labor hours, it's 2,300 units. For standard direct labor hours, which would be standard quantity, okay, so standard direct labor hours is standard quantity, and remember, for standard quantity, we take how many hours we think it should take to make a unit and multiply it by the actual number of units. Okay, so for standard quantity, we take how much we think it's going to take to make a unit. So in our case, it's 4 direct labor hours. Multiply it by how many direct labor hours were actually, multiply it by how many units were actually produced. And this tells us the amount of direct labor hours we think that should have been worked. So we should have worked 2,400. We actually only worked 23. So we were efficient, so that's great. So it's going to be favorable. And again, variable overhead efficiency and direct labor efficiency are identical.